This only one. Okay, so this is merging. Okay, guys, got it? Okay, so is that okay? In any step, do you have any questions on this? All good, right? Okay,
Yes.
okay. And any questions? No, right? Okay. So now let's try with stiffener also. Okay. Let me have to go and 2 from create a plane. Here is a plane. Okay. From offset from this side, it is 22. Okay. Okay, guys. We have created a plane here. Why? Because this rip is starting 22 mm from this surface. Okay. So at this plane, let's try with the rip. So I created a plane here. Now the problem is, again, here you can remember, while creating this plane, I selected this face. Okay, that means this plane is connected to this surface. Okay, so best thing is always select something from this axis itself, so that you can have link only with the axis system. Okay, so what is the difference between this 30 mm? So let's delete this and say 30 mm. So here 30 mm, review and reverse direction. Okay. Now this is purely connected with the axis system. So here, okay, Let's quickly extract and see how it behaves. Okay, this, this. Okay, close, close. Enough. You must use an open profile. Yeah, for stiffener we have to use open profile. Okay. Okay. Open. Let's see how it is going. What is the HMI? Okay, and we need to have one more script here. So say there is a mirror option here. Yes. Yes. Say now. Okay. Okay. So we saw two methods of creating these difference. Okay. One with the help of pad and pocket, and with the help of another one with the help of only stiffener. Okay. You must know both the methods so that whenever they ask you sometimes they say in there will be some rules and regulations like based on the softwares what they are using. Maybe you will be designing it or you will be modeling it in Catia V5, okay, and you will be sending to them, and the OEM they will be using different softwares where in some softwares they may not find that feasibility or it's not compatible with some of the options in the Catia V5. Okay, they cannot see that when they convert it, migrate it to that software or some other software which they are using for the manufacturing process or something. If they open it in their softwares, some of these features will disappear. Okay, maybe stiffener may not work there. In that case they will specially will ask you to do not use this stiffener, okay, or do not use the some people will ask you not to use this thickness. Okay, what is this thickness? See what is the this is 9 mm. Okay, in case if you want to increase the thickness of this you can simply use this option, click on this and select the surface and say 2 mm. If you want to add 2 mm here, then this will increase the thickness. Okay, no need to again get into the sketcher and see. Now it is 11 mm. Okay, so 11 mm it increase. So if you want to increase more, you can add. Okay, 10 mm if you want to increase, you can increase. Okay, this is the purpose of this. But uh, customers some agree with this, okay, they accept this feature, some don't accept this feature. That's the reason you must be able to uh, create with all the features. Okay, for example, stiffener, if they ask you to prepare with this pad in the pocket, then you must be able to do that. Or if they are okay with the stiffener, then that's fine, you can go ahead with the stiffener itself. Okay, so here we have not so all these things are not required. So you can simply delete and then Okay, guys. So we have seen two methods to for creating the stiffener. Okay. Have one more class. It seems. Okay. It's still 6:45. No problem. Okay, guys. Any question with this? Ah, I'll show you this. You want to see this, right? The if you double click on this, you can see the coordinates here. Okay. Say more. Then you can see 0, 0, 0. Okay. Now, if you want to change these coordinates, you can change it. Okay. See, the axis system is moving. Okay. Now, it close and say okay. Is the part okay? See, in this area, some issue with this feature. Okay. So this has got some issue. That's the reason this is not moved along with this. Okay. Move, say 0. Okay. Say okay. Now it's okay. So this feature has got some issue. What is the problem? The mirror is not moving along with this. Why it is not moving? We have selected this axis system only, right? This, which plane we selected? Axis system only. But still it is not moving. Mirror it, axis system we have used. It should move actually. So these are the problems you usually. How they check? They when you complete a model, so immediately they get into the sketch and they check the sketch. Okay, how you have done all the things like is everything constrained? Okay, they are going to see if everything is constrained. Okay, and how you constrained it. All the dimensions as per the drawing maintained, or randomly you maintain some dimensions. Okay, that they are going to see. From where you dimension, that is also they are going to see. Okay, and they are going to check if everything is fine with this. Okay, and the next check is this one. They just move the part. Okay, say 100, 100, say okay. There is some issue with the stiffness of the joint. Which stiffness? Stiffener is not moving. Why? Why it is not? Okay, this is how we have to check actually. Stiffener is not moving, so there is some issue with the stiffener. Okay, I'll check it later. Okay, so this is how we have to see. So whole part is moving. We need to make sure that whole part is moving. Let's go back. I'll show you a simple pad and then I'll show you how it moves. Okay. some features always they give trouble, so we have to be very careful while creating those features. For example, system, okay. Now perfectly, there are no other features, so it's easy to show you how this part. For example, 50M. Now, that's the system. Hide the lanes. Second, let me say under, under, okay. Close it. It's fake. It has been then guys, it is not moving. Some issue with the license or something, I don't know. But it has to move actually. That's how it works. Okay. So let me check. Let me check, and in next session I'll show you how it moves. But this is how we have to model, so that even if you change the coordinates here, okay, that along with the access system it should go, because it is directly connected with the access system. Why it is not moving? Check once again. Okay, that I'll show. Okay, so let me check what exactly is the issue in this. Then I'll show. But that's how they check usually whether the part is moving or not. Okay. Okay. Okay, guys. Any other questions in this?
Sir,
Yes, please.
sir, can you show the diagram, the part drawings?
Yeah.
Thank you, sir.
So keep it side by side. Okay. Okay, have a look at it. Let me know your questions if you have any. Let me have a glass of water, please. Okay, guys, any questions?
No,
Done, right? So as we discussed initially, if we want to follow exactly the manufacturing method, then what we have to do? First, we have to take a block of metal, okay, a block of this height and this width, and then we start removing material, this material, and we'll achieve this profile, okay, this pocket. First step will be the complete block, okay, and second step will be removing this material, this side completely and this side completely, okay, and then adding these ribs, okay. There will be around 3 to 4 steps in that, okay. But now what we did completely, the front view complete profile we have taken, okay, we have considered complete profile and extruded it and then added the ribs.
Rupees 143 received on phone pay.
Okay, guys. Okay. So, any other questions? So, till now, what models we did in that? If you have any questions, please let me know. Because for you people, I'm going to distribute same models. I'm going to give you. Okay. Please model them and submit them maybe within a week so that I can check everything and we can go ahead with the process, further process. Okay, that will be communicated to you. If you have any questions or anything, you can ask me. So we have
sir,
yes, please.
sir, if you do the design in manufacturing method, can we use it in CNC process?
Sorry, louder, please.
If we do the design in manufacturing method,
Yeah, yeah.
can we use it in CNC process to design the it in real places? Can we use the manufacturing method in the CNC method CNC machine?
You mean to say this directly into CNC?
Yeah, yeah,
You design it and directly to CNC, right?
yeah, sir.
Yeah, they have
Yes,
some
sir.
other software, intermediate softwares they are using actually. This directly, this won't go to CNC. It's not possible. Okay, that's
Can
from.
we
Sorry.
can we use the process exact what are the machines we are cutting? Can we use the process to design? Can we use this process in that software and we can manufacture it? Can we?
No, this directly cannot be done.
Okay,
Directly cannot be done. Okay, so
okay,
this definitely this methodology, Catia, they are going to use it, but they have some other intermediate softwares where they are going to convert this, okay, into their format, okay, and then they are going to create generate a different program using this. So that's the reason uh, different OEMs, like different manufacturing units, are using different softwares. That is the reason they say sometimes don't use this. For us, this pad is not required. Okay, don't never use this thickness option because these some of these options are not compatible with their softwares. you design everything in this. Okay, you model this part using this thickness or shell. Some people they say never use shell. Okay, so that's not compatible with our softwares. Okay, that's the reason there will be differences. Okay, from manufacturer to manufacturer. Say we have different customers. Okay, so this customer will say no, you use only this pad option, and whatever you create, you please add wherever you want to extrude, you use the pad. But someone say no, please don't use this. Okay, don't use rib options, don't use thickness options. So there will be difference in that, but you should know how to uh, model it using all the options. But when you are particularly working on a particular project, then as per their rules and guidelines, you have to model it. Okay, that's how we have to do. Any other questions? Okay, so as of now, whatever parts we did, so hope you people can model it, right? So I explained you step by step, and how to constrain it, how to take the access system. Okay, so I think everything is clearly explained. And if you have any questions, you can ask me anytime. But when I start sharing the parts, okay, drawings, I'll share with you. And you start working on them. Okay, next week, maybe tomorrow, I'll share with you. Tonight or tomorrow, I'll share with you all the drawings, and you can start working on them. Okay. First, select as how many teams? I think 6 teams are there. So six of you can select different parts and start working on them. Okay. If you have any questions, you can contact me. We will see if you are facing any trouble, or if something is not clear, the dimensions are not clear, or the information given in the drawing is not clear. Okay, because of which you are not able to complete the drawing. Then we'll see. We'll look into that, and I'll provide you needed information. Okay. Okay. So now, if you have any questions in previous models, I'm ready to explain you. Okay. If not, we will see the sheet metal part. I'll show you one sheet metal part.
Sir, so in these drawings, after we are offsetting the plane, right, for making that middle part using stiffener, we
Yes.
are offsetting the plane, right? But when I'm starting the drawing, sir, again it is coming to that back, means the same plane where the whole diagram is made, sir. Means how should we make that drawing to be on that plane, sir, which we are offsetting?
I'm not clear about the question. We offset it. Okay.
Yeah, after offsetting, sir, when I'm continuing my drawing, it is still in that old position, sir.
So, for example, the plane we offset it. Okay.
Yes, sir.
So after
What now? What is the next step now, sir?
offsetting this, you have to select this plane. Okay. Select this plane and then go to position sketch. Okay. Initially, what we did, we selected this plane, ZX plane. Okay. Now, why we offsetted this plane? Because this feature is exactly sitting here. If you select this face, the feature will come here, right? Because this sketch will be created in this location. Got it? What is the purpose behind this offsetting the plane? Because we want something here, this rip to be generated It should be generated in this location. That's the reason. This is the base where we are generating it. Okay. So
So we have to select. We have to
yes,
select that plane and click on
yes,
position sketch.
exactly. So select that plane and then go to position sketch. Okay. Now I selected this, and after selecting, where is my sketch now? See, this is the plane I have selected. That's the reason my sketch is here. Okay. If you select this plane, then the sketch will be in this location.
Okay, so got it.
Yeah, that's the reason. You have to offset it. Good questions. Any other questions? These are the basic questions when you start learning Catia. Okay. So keep practicing. You will get many questions. Okay. We can discuss clear on that. Any other questions, guys? So last time I think we saw some models. This model is done. Yeah. So guys, they have you achieved this profile? This profile was a little bit difficult on that day. Okay, don't hesitate to ask me if you have any difficult like situations while creating that. The main thing is you have to constrain the sketch properly. So that you have to learn first. Okay, because just you are doing it, learn how to constrain the sketch properly. Okay, that will that is very important. Unless you have good sketch, you cannot proceed to next step. Okay, you'll get a lot of error messages. So that's the reason you have to construct it properly, and you have to constrain it properly. You should know how to make it green properly. Okay, so any questions in Sketcher related to anything? See, in Sketcher itself we can give this fillets also. See, kind of, you want to give fillets here, you can give this also here. Okay, but this is not recommended. Okay, these fillets are not recommended in Sketch, but if they ask you to give in Sketch itself, then you also can give it in Sketch itself. Okay, you have chamfer here, you have fillet here. Okay, but usually you always use it here in part model. Okay, you can use here this fillet, edge fillet you can use, not in the Sketch. That's not recommended, but the provision is given there also. Okay, for fillets. Okay. And you know how to insert access system. Okay, this part is moving at least. The one which I created to show you, that's not moving at all. This part, some issue with the. I'll check it. Okay, so let's have a look at the part. Okay, sheet metal one. In last class we saw. I showed you how to create using shell, right? What is the use of shell? I showed you. I'll show you. Maybe we can take one drawing. Last time I showed you, if you want to create a simple like this. I'm not constraining. Okay, just take your time. Okay, this part and this is kind of bracket. Okay, then initially you have to give edge fillets. Okay, to avoid sharp edges, you have to provide edge fillets. Maybe based on the requirement of the or the drawing what you have received. Okay, you have to keep like this, and then if you have any holes already, then directly you can you have to select the face. Okay, let's see. So this is my orientation of the thing. So that's here. Okay. Say up to next. So this hole is done. If you want to have few more holes, you also can use this pattern. Okay, this hole. You can select the hole and how much distance you want. If you want to have two, then two, or what is the distance you want? If you want to have 50 mm, okay, 50 mm hole. You want to have 5 holes, never on the edge fillet. Okay, so 4. You can use this pattern like this. Okay, this is the pattern. Okay. select the role, okay, click on the pattern and reference element. So which is the reference element? This is on which surface the hole is available, okay, the reference surface. And the instances, how much, if you want to have 3 instances, you can say 3. And what is the distance between the holes you want to maintain? Maybe 50 mm. Okay. Okay. Do like this. Okay. Okay. And then say shell, and you have to select the thickness. How much? What is the thickness of the sheet? Maybe 3 mm thickness. Okay. And default outside thicknesses. We don't have any faces to remove. Okay. This is the face I want to remove. This is the face, and this is the face. And just let's. I'm not selecting these holes right now. Okay. Let's see. If you don't select that, this is how it will leave. Okay. We have to select the holes. Select, select, select. So all this material, okay, all this material. You want to have a dent here, then go back, say pocket. Okay, I don't want this. Say delete. So I want something. This is going to ask you where are the missing faces. It's always good to. Okay. Now after this pocket, see if I want a dent here. Okay, I want to have a shape here. Then let's select this. Okay. First, okay, this view. I want something material hole here. How to do a circular thing? I'll show you. To the cylindrical thing, how we can do that? Okay. Delete this. Say extent. Okay. Now let me select this. Okay. This is my axis. Okay. I want to have kind of let's say this. Say container here. Now I'm coming out. This is this and this trickle. Okay. If I want to have circular material, this, and about which axis you want to remove this axis. Okay, so you can remove material like this. Okay, or remove material. Then I have, before giving thickness, we need to now oh, we have already this so you can see this kind of forming operation. Okay, so for this, if you want to get kind of forming operation like this, so this is how we can do it. Okay. So you have to remove the material and then you can apply the shell operation. Okay. Okay. So guys, any questions on this? We'll work more on such kind of models in coming classes. I'll show you some more testing options. Okay, like other options also where circular pattern you can use. Okay, circular pattern also I'll show you. Because this land is not enough. You can give, for example, this is here circular pattern. Okay, this is, let's select this. So how much is the angle you want? Okay, 45 degrees, and then say 5 holes I want on the reverse direction we want. Okay, we want reverse direction, this direction. Okay, these are going out of this, so we'll say only 3. Okay, these are the circular patterns. Okay, you can use them. If there's a big part, then you can have a number of holes using circular pattern also. Okay, so I'll show you next coming classes how to use these user patterns, and all these patterns we'll use. Okay, other important things we already use them, but I'll show you how to use things. Okay, guys. So, any questions in this till now? Let me know any questions. If everything is okay, then we'll continue in next class. Okay, it's already 7:25, so maybe today another session is going to start at 7:30. That's the reason we have to leave now. So, guys, any questions? So I'll share the drawings. Okay, and please start working on that. And if you have any questions, you can contact me. Okay, let me know you.